I'm just going to tell you this stuff works. For those of you that were at our garage, we have 2 of their fans in our facility. We absolutely love them. I know Fayetteville's got one as well. Winston's back there shaking his head. You guys love yours? In the summertime, your air temperatures go down. You have that constant air movement. In the wintertime, it pushes that hot air from the top back down, so you maintain a constant temperature throughout your building. Frank will talk all about that, but we just absolutely love ours. Go by and see them. Get that contact information, because you guys will benefit from them, I promise you. Without further ado, I'm going to turn it over to Frank Schoen. Give him a warm welcome.
Thank you guys for having us come here to speak. Thank you, Robert, for the warm introduction. First, before I start, has anyone else heard of Big Ass Fans before coming here?
All right, great. So it seems like the name gets around. Everyone loves to make fun of us, and we kind of love making fun of ourselves too. But what I'm going to talk to you about today is there's actually a lot of really good science that goes behind our products as well. So first I'm going to introduce the company a little bit. It's a really cool story of how we got started. We started in 1999 as the HVLS fan company. I know it's a mouthful to say. It stands for high volume, low speed, which is the technical term for the type of ceiling fans. We got started because there was a UC Davis study that came out that said happier cows make more milk. So our original clientele were actually farmers. Now these were more of rugged outdoor spaces, so you couldn't really air condition these spaces. But by putting a fan in, the cows were more comfortable and were producing 15 to 20% more milk. So for farmers, it was an obvious no-brainer. However, after the first 3 years, if you imagine that kind of clientele, when farmers would call back and order more fans, we'd answer the phone, "Hey, this is the HVLS fan company." And they would say, "HV what? Are you the guys who make those big-ass fans?" And after hearing this about 1,000 times, we actually rebranded our name and changed our company name. Since then, we've actually become the world's leading manufacturer of large ceiling fans. We have international offices around the world in Singapore, Malaysia, Australia, Hong Kong, Canada. We're going to be expanding to India and Mexico in the near future. We have installed more than 100,000 fans worldwide. We're the only company to manufacture, design, engineer, test, and install our own products. So we don't work with distributors. We all sell everything factory direct. We install factory direct. The term we like to use within the company is you have one neck to choke or one back to pat. So if anything goes wrong, you know who you're going to deal with. And finally, we're really proud that we're the only company to have a certified testing facility dedicated to only large volume fans. So we're really committed to what we do. One thing we're really proud of is also our product timeline. You know, in 1999 we started with one product, worked really, really well. Instead of just selling that product over and over again, we've developed a whole 2 new lines of fans, and instead of most fan companies will have 3 different products, we have about 20. And most recently, as Robert said, we got into the LED lighting business. This is because a lot of our clients were in the warehouse, high bay spaces. They also were looking at high bay lighting, so we actually designed a light for that space. We have a fixture down our booth. I won't go too much detail about that. Feel free to come down and check it out later. Drop a business card, and we're giving away some free lights at the end of the show as well. So now we're going to talk about designing for thermal comfort. Is anyone here familiar with ASHRAE? Anyone? Okay, ASHRAE stands for the American Society of Heating, Refrigeration, and Air Conditioning Engineers. So these are the guys that write all the code and language to define comfort and mechanical equipment and mechanical design. ASHRAE standard book is actually used as the guideline and the baseline for most building codes, as well as advanced sustainable codes such as LEED, CHIPS, green globes, and any other kind of green standard. So we're going to talk about thermal comfort, which is one of the things that fans will help affect. ASHRAE definition of thermal comfort is the condition of mind which expresses satisfaction with thermal environment and assessed by subjective evaluation. I know that's a mouthful, but in short what that means is when you're comfortable, it's when you don't perceive any discomfort. The most important words of this statement is subjective evaluation. Comfort is very subjective, which means my standard of comfort may not be the exact same as someone else's standard of comfort. I may run warm all the time, and someone next to me might be cold, even in the exact same space. So as designers, what you do is you create a space that satisfies the majority of people's comfort. And by then, by definition, and by the standards of ASHRAE, you've created a comfortable space. So what is thermal comfort? According to ASHRAE, there are 6 standards that affect thermal comfort. I'm actually going to go back. Can anyone name any of the 6 factors that affect thermal comfort? Guys got a sneak peek as well.
Humidity.
Humidity, it's one. Temperature.
Airflow.
Airflow, very good.
Clothing insulation.
Clothing insulation, that's right, that's a personal factor. All right, I'm sorry? No, that's not right, because the other factors, that doesn't affect thermal comfort directly. We'll go ahead and reveal the answers. So there are 6 factors, 2 personal and 4 environmental. The difference is that the environmental ones are what the facility managers and building designers can control, while the personal ones are completely personal. We'll start with the personal one. One is clothing insulation, also known as clo value. This just means that the more clothing you wear, the better insulated you're going to be, the better your body will retain heat. As a building designer or facility manager, there's not really much you can do about that. The second one is metabolic rate. Metabolic rate, also known as MET, is based on 2 factors. One, what your natural metabolism is, and 2, what kind of activity you're doing. If you're going to be running around, you're going to be a lot warmer because you have a higher MET rate. And also some people naturally will have a higher metabolism, which means their body will create more heat naturally. Now, as facility managers and maintenance guys, what you can affect are the other 4. The 2 that are always named first is relative humidity and air temperature. Those are the 2 things that are traditionally controlled by HVAC systems and what people traditionally think about when creating comfortable environments. There are 2 others that people don't often think of. The first one is radiant temperature. So this is heat that's gained by your body absorbing radiation. Example I like to use is if it's a really hot day outside, people are going to naturally run to shade underneath the tree. If one person's underneath that shade and one person is not, that person underneath the shade is going to be a lot more comfortable. However, the air around them is going to be the exact same temperature. The humidity is going to be exactly the same. It's the fact that they're not absorbing the sun's radiation and they're not getting any of those radiant gains that they're much cooler. And finally, the next one is what big ass fans can affect, and that is air velocity. Air velocity is measured in feet per minute. And an example I like to use is on that same hot day, if a really nice breeze comes in, everyone's going to feel a lot more comfortable. If you look at the other factors, the temperature of that air is still the same even though it's breezing across you, and the humidity and the radiant gains is still going to be the same. By having that airflow move across your skin, you're going to have a perceived cooling effect that's going to make you a lot more comfortable. So when we go to design buildings, there are 2 ways to measure whether or not you create a comfortable space. The first one is the predicted percentage of dissatisfied. So this means how many people are going to be dissatisfied with your space. According to ASHRAE, as long as less than 10% of the people are dissatisfied, or meaning you've designed a space that 90% or more people are comfortable with, you've by definition created a comfortable space. The next one is predicted mean vote. This is actually based on a survey that's taken post-occupancy. People define their comfort from a +3 as being warm and a -3 to being cold. And as long as you're within that -0.5 to 0.5 neutral range, then you've created a comfortable space. Again, it means the majority of people are satisfied with the space. So this is actually a tool on the left called the Berkeley tool. It's from the Center for Built Environment from University of California, Berkeley. It actually will tell you, it will simulate a space when you go to design it and tell you whether or not it's comfortable. So we actually went ahead and inputted a very, very typical building space. 75-degree temperature, 50% relative humidity, one MET rate, which is very standard for someone who's in an office space or even just doing light activity. clothing insulation of 0.5 to 1, and airspeed of 40 feet per minute or less. Now, what 40 feet per minute or less means is that you can't feel anything. 40 feet per minute is the threshold of perception for humans. As you can see by the definition, the PPD is 8%, which means over 90% are satisfied, and the PMV is within that negative 0.5 to 0.5 range. By definition, this is a comfortable space. Now what we're going to do actually is offset that thermostat. Instead of having 75, we're actually going to turn it up to 80, 5 degrees. We're going to use this chart. It's not very clear, but there's a curve over there, and it says, and there is a kind of a correlation between how much air movement you have and the degrees of thermostat you can offset. So by adding 120 feet per minute, we can actually offset that to about 5.5 degrees. As you can see here, we did exactly that. We turned the air temperature up to 80 degrees, and all the other conditions are the same, except airspeed is now 120, which is enough to feel that perceived cooling effect. And by ASHRAE standards, we've actually created a lower percentage of dissatisfied, and our PMV is close to that neutral 0, which is what we want. So this space is just as comfortable, and what you've done essentially is use a lot less energy to cool that space down. And according to the EPA and the Department of Energy, which each degree of thermostat offset, you can save between 3 to 6% on your cooling bill. So that's where the energy savings comes in. This 5-degree difference will result in 15 to 30% of savings. Next thing we can affect is indoor air quality. We'll go over this relatively quickly. Essentially, we'll take this building for example. Along the top over here, you can see that there's diffusers where the conditioned air comes out. And across the side to the left here, there are 2 intakes where it goes back in the system. Now, when mechanical engineers design spaces, they know that they have to oversize the system because of a loss factor. If you imagine, in the wintertime, heat naturally rises. So when you have to have a certain amount of fresh air circulation in this space, they know that a part of that is going to come out that diffuser over there, go straight across the space, and go right back into the system without ever reaching the occupants on the ground level. So what they do is they oversize the system by about 20% because they account for a 20% loss factor for this short circuiting. Now, what we can do is by putting a fan in that space, you can actually guarantee that air from the top goes all the way to the bottom where your occupants are in that zone that they'll actually experience that fresh air. And if you do this on a new construction side, when you guys go to design buildings and create new spaces, you can actually reduce the tonnage of your mechanical system, which creates a lot of initial upfront first cost savings. So it's not just operational for big ass fans. If you use fans on a design from the start, you can get savings from day one. With a floor system, the loss factor according to ASHRAE is even higher. It's 30%. So now we're going to talk about another form of energy reduction. ASHRAE standard 90.1 accounts for minimum building energy efficiencies, and then they actually go further with 189.1, which talks about what the standards are for green buildings. Essentially, all ASHRAE says is the less energy you use, the more green you are, and if you can achieve a certain standards, you can be certified as a green building. How we can affect direct reduction of energy usage is through destratification. If you think about a large fleet facility, a high bay facility, you're going to have 30, 40-foot spaces. In the wintertime, you have to dump heat in that space. Heat naturally rises, and that's going to be pooled at your roof. What happens naturally is, if you see the diagram on the top right, there's going to be a delta between the temperature between your ceiling and your floor. The delta is going to be about 20 degrees, very typically, which means that you're heating the space from top down, and unfortunately all your occupants are on the bottom. If you also have a low R value for your roof, all that heat actually and all that money that you're putting into heating is going to go flying right out your roof. Now what you can do, what we recommend doing, is by putting a large fan to circulate that air. That fan is going to push that hot air from the ceiling all the way down to where your occupants and your thermostat is, so that the delta, instead of 20 degrees, it might be only 1 or 2 degrees. This destratification, or taking away the stratified air and pushing it down and homogenizing that space, is going to create an energy savings about 1% per vertical foot. Now this tapers off about 30%, so you have a 100-foot space, you don't get 100% savings, but it's really significant, and it's the quickest way to get an ROI for your big fans. Now, does anyone have ceiling fans at home? Okay, most of you. Now, what do they tell you to do with your fans in the wintertime? Reverse them, that's right. Many people come up and ask us, would you recommend reversing your fans in the wintertime? And the answer for us is no. So, your fans at home, most of them will have a pull chain that adjusts the speed. They'll have 3 speed settings, and once you finally figure out that you're on the lowest setting, you're still going to feel that you're going to have a significant breeze. It's above that 40 feet per minute that we talked about earlier, and it's going to create a perceived cooling effect, which is not what you want during the winter time when you're trying to heat everybody. However, our fans all run on VFDs or direct drive motors. Therefore, they can go from essentially 0 to 100%, means we can make it low enough that they turn the air and turn over that air without feeling that perceived draft. So there's no perceived cooling effect. If you think about how a fan naturally how air would naturally want to move, air is a fluid. It's going to take the path of least resistance. So if you want to get that hot air down from the ceiling, it's much easier to push it down directly than to push it back up, have it bounce against the ceiling, bounce against the walls, and have it make it down. As a matter of fact, when we do testing, by doing a forward motion, it's much more effective. You have to only run a fan about 25% energy to get that, to destratify that space. Well, if you reverse it, you have to run it at over 80% of its full power to get the same amount of air back down. And as I said earlier, because we're turning at such a low speed, you're not going to feel any of that perceived cooling, because there's going to be no draft, and there won't be any cooling effect with that air going against your skin. And finally, I like to show this chart. This is actually taken from CBEX. It's another EPA organization. They survey buildings, and they actually collect real energy data. This is the chart for all, this is an industrial average for all Oklahoma commercial facilities. So this doesn't include anything residential. And this is where the energy goes to. As you can see, 30% is of the energy in BTUs is consumed by heating, 12% by cooling, 8% ventilation, and 18% lighting. Big ass fans, we talked about the other 3, and we also do LED lighting, which can reduce your load, your total lighting electric load. That means that our company can help you reduce even a fraction of energy on about 70% of your building energy consumption. Reducing even a small fraction of that will create really, really significant monetary savings. And that's it. Does anyone have any questions?
When I went to the Muskogee shop the other day, I noticed that the fans were a long ways away from me, but I could feel the air 3 round ways. I mean, fans on the other side of the building, but I could still feel the air moving around me. How do you do that with your fans?
So if you look at our fans, at the end of the blades, we have a wingtip technology that's very much based on aeronautics and airplane technology. What that does, it actually pushes the air out in a conical form, so that it doesn't go directly under you. The benefit of the fan is that a fan doesn't move air just directly on the floor. What's going to happen is it's going to push the air sideways, and even the air that hits the floor, it's going to bounce against that floor and spread out. Our coverage for our large industrial fans, which is the ones they have in the Muskogee facility, well, the coverage is about 2 to 2.5 the diameter of the fan themselves. So you don't have to have a fan over every square inch of your ceiling. You're still going to get a coverage so that everyone underneath is cool.
Are these all, are they just hang fans, or are they vent fans, or how's that?
So our fans, we don't deal with ventilation fans. That's a whole different business.
I mean, real fan type, exterior ventilation.
No, so we do only interior, and we do much. Our fans are all dedicated to air circulation within a space. So we maximize the circulation, the air movement that's already inside the space. Now we do have directional fans as well, so ones that you can push through the door, some that are larger for outdoor events, etc.
How do they do in an environment that is smoky and is, you know, exhaust fumy? Because that's kind of part of the question too. If it's in a pretty nasty environment,
So the fan that actually is in the Muskogee fleet, that has a very unique motor. That gearbox is nitrogen sealed, so it's hermetically sealed so that no particulates will get inside. We're used to putting fans in all kinds of industrial spaces. Now, if there's a certain certification, we can certainly see if our product matches it. But if it's really smoky and there's some indoor quality issues, a fan will naturally help the ventilation and help your ventilation system. Think about it, it's going to turn that air more so that more of it gets out quicker.
Just a quick comment. My shop is CNG compliant, so one thing you have to look at when you're hanging your fans is to get them below the CNG sensors, so that when the gas builds up in the top, it doesn't get into the fan before it gets to the sensor. And that's something we had to address in our shop, is to make sure we were below the sensor level, so the fan's not running in compressed natural gas that we have to leave.
Point.
does your company have local reps or something? How does that interaction with your technology? Someone come to a site or how?
Yeah, so the approach is air movement is very finicky, especially if you have any kind of industrial space. You might have racking, very unique situations that might interrupt airflow. There's two ways we like to conduct things. So Erin Hall right here, she is one of our design reps. So if you guys are just curious about design concepts and want to hear the ideas of the fans and want to hear the design concepts, we have reps, her and a guy in Dallas. They cover Oklahoma, and they'll come meet you. We'll schedule a time and they'll come talk to you. Afterwards, if there's a particular space you're interested in, we'll do a custom survey free of charge for every single space. This way we have someone see the space, know that where we're going to hang the fans, how we're going to run electrical power to it, and then to make sure that we can maximize airflow and to make sure that we have full coverage of your space.
All right, I've heard that there's customers considering using these fans and excluding exhaust systems. Is that anything that's being propagated by the gas?
Definitely not. I would definitely say that's not something we want to say we're experts in. I certainly wouldn't say that, at least. I don't come from a mechanical engineering background. I would definitely check with your building's mechanical engineer before saying that. I would never say that our fan will 100% replace your exhaust system. As a matter of fact, I think I would actually say that it'll help supplement it, especially for aging systems, but in no way should they completely replace air circulation or air ventilation in that space. All right, well, thank you guys. We're going to be at our booth. If anyone's interested, feel free to stop by. Thank you.
I just want to say a couple quick things. Big Ass does not pay me to say these. I'm just a firm believer in their product. I want to share that with you people. That's what we're here about, is to network with one another. When we find something that's great, we want to share those ideas. For those of you that haven't been to our garage and seen those fans, I highly, highly, highly recommend it. I know Greg was talking about them there. They come in, they engineer where they're going to locate them. They have to be so far apart or they work against one another. So where they strategically placed ours, it allows them to work in the most efficient manner. We have 4 large natural gas heaters, one in each corner of our shop. And it is very, very, very rare that we have to turn on more than one of those. Just one with those fans constantly moving that air around, keeping it at a comfortable temperature and an equal temperature all around. We don't have to run 4 of those big heaters in the wintertime, so our utility bills just were cut in more than 50%.
You all have any kind of coolant flow into your area during every summer. We died this summer. We had no air conditioner at all in our big building, and we couldn't respond to the humidity so well.
We currently do not, but we have overhead doors on every one of our exterior walls, so we get that natural ventilation from whichever way the wind is blowing. And with those fans, it is very, 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 very comfortable. Go down there and just talk to the technicians. One thing that we do have is we have the stand-up barrel fans for when you're working under the vehicle and that air is blocked from the vehicle. That air gets pushed sideways directionally. It is very, very, very comfortable.
Do you work with your doors open or halfway open or partially open to avoid radiant heat coming in from the sun certain times?
No, we keep them open all the way. We have vents in the top of our roof that we open up that allow the heat in the top to escape in the summertime and then close them in the winter to trap that heat. But it is, I believe in them 110%. And I want you guys, if you're considering them, there are some out there that are 10 to 20% cheaper. We looked at those. I went to places that had them, and they do not move 1/3 the amount of air that these fans did. It was a no-brainer decision for us to go with these fans. And just like I said, talk to Greg. When you're standing there, you can feel it from a long ways away. It is unreal, and they're whisper quiet. They're amazingly quiet. Those fans were huge for us. Happy employees are productive employees. The Identifix online repair solutions, if you haven't been to their booth, go down there and see them. They were huge for us. Cummins Insight diagnostic software was huge for us. Those are just a couple of things that I can mention. Go along with the right tools and the right equipment to do the job, and get your guys the training. That was a game changer for us. We outsourced very, very little. And the stuff is very, very reasonable. The return on investment is nearly immediate. If you got any questions, come see me. But the big things, and that's why I had big ass fans here, Identifix here, and Cummins here, because they were game changers for us. They improved efficiency by 30% or more by being able to do everything in-house and reduce the diagnostic time that was required to figure out what was wrong so we could fix the vehicles. Go by and see those guys, get a card from them. They came a long way here, and I know they'll be game changers from you.